Hi, guys. So today I'm going to be walking you through lesson 7.3, which is an introduction to logarithmic functions. You should have hopefully watched the Google Calculator video to kind of explain how to use Google Calculator because you'll definitely need that for this lesson, or if you have your own scientific calculator, you can use that as well. Um, this is kind of how lessons are going to be from now until we go back to school. I know it's going to be more difficult to learn this way, so just make sure if you have questions or you aren't understanding something that you definitely contact myself, or Mrs. Spazzelli is available to help as well. You can do that via email, or you can message me on Remind if you have the Remind app and you're signed up for Remind. So this section is over log functions, and you should have watched an Edpuzzle video kind of giving an introduction to log functions. I know for some of you, you watched that video 3 weeks ago, so you might not totally remember it, and that's fine. So logs are basically just another way to help us find exponents, or another way to represent exponents, or an exponential relationship. So when we think about exponents, and we know 2 to the second power is 4, we know 2 to the third power is 8, how would we solve for x in 2 to the x power equals 6? We know that this, since 6 is in between 4 and 8, we know that this power would have to be something in between 2 and 3, some sort of decimal, 2 point something. So if we needed to solve and find that specific exact value for x, we could use logarithms to help us do that. So that's kind of the whole point of logarithms. And later on in the unit, we will solve equations and find that missing exponent. So we're just going to kind of go over the definition of a logarithm first. And this was explained in that Edpuzzle video if you still have that fresh in your mind. So you have the word log, basically, that just stands for logarithm. And then you have a subscript, and that number is your base. So I've labeled it with a B, just like it did in the video. And then N right here just represents a number, and it equals P, and that represents power. So B is base, N is a number, P is a power. This relationship is true if and only if the base raised to the power equals the number. So this base to this power would have to equal the number right here for this logarithm to be true. So the first thing we're going to do is we're going to take logs and we're going to rewrite them in exponential form. So we're going to switch them from log form, which is right here, into exponential form, which is right here. So if I have log with a base of 2 of 32 equal to 5, that's the same thing as my base of 2 raised to the 5th power equal to 32. So it kind of goes in a circle when you set it up. And if you typed this into calculator, 2 to the 5th power, you would get 32. This is true. So it should always be a true statement when you rewrite it in exponential form. If I would have rewrote it like 5 to the second power equals 32, I would know that that's wrong. This isn't the right exponential form for this log, because 5 squared isn't 32. 5 squared is 25. So once you write an exponential form, you should just double check and make sure it's true, and then you know you wrote it in the correct form. Okay, part B has a log base 5 of 1 equals 0. So you always start with the base. So your base is 5. Here's your power. Here's P over here. So my power is 0 equals the number, which is 1. Anything to the 0 power is 1. So I know that this one's right because 5 to the 0 power does equal 1. And then part C, I have log base 100 of 10 equals 1/2. So I start with my base of 100. Here's my power. 1/2 equals my number 10. Remember, a 1/2 or a fraction power is the same as a root. So this is really saying the square root, because that's equivalent to a half power. Square root of 100 equals 10. I know that's true. Okay, so in example 2, we're going to switch them from exponential form like we just wrote them. They're starting out in exponential form, and we're going to write them in logarithmic form. So we're just going backwards. So the first thing I need to do is I need to write the word log. First number I see is my base, so I make that my little subscript number, so log base 10. And then basically these two numbers just flip-flop. So I would put 0.1 and then equals, and then my power, which is -1. Okay, and remember negative exponents, just so we understand this relationship here. Negative exponent, remember you'd move to the bottom of a fraction to make it a positive exponent. So this is equivalent to 1 over 10 to the first, or 1 over 10. 1 over 10 is the same as 0.1, just the decimal form. All right, part B, log. First number I see is 1/2, that's my base. These numbers switch, so I would switch and I put 2 here, equals, and then my power of -1. Okay, similar concept to part A, just explaining the relationship here. A negative power, basically, if it's already a fraction here, it flips your fraction. So I'd flip it to 2 over 1, and my power would change to positive. This is just saying 2 to the first power equals 2. Okay, and then part C, log form. Log, my first number is my base, so base 16, and then I switch these two parts. So of 4 equals the power, which was 1/2. Here we go. Remember, half power is the same as the square root, so this is just saying the square root of 16 equals 4, which it does. Okay, so that's just rewriting from one form to the other. Example 3, we're going to evaluate these log expressions. So you can see in these examples down here, you don't have the equals, and then you don't have your power. So we're trying to find that missing power, because I know that my power is what goes on this side right here. So you could put equals P if you want, and you're trying to figure out what P is. So the first thing I would do is I would take the log and put it in exponential form, and that will help you kind of see what you're trying to find, and it will help you find it. So remember, you start with your base of 3, your power equals 81. So we're trying to figure out what power of 3 is going to give us 81. So a calculator is definitely going to help you with doing these. So I'm going to quickly go to Google Calculator, and it erases it every time I click off. But I'm going to try out some different powers for 3 to see what gives me 81. If I try 3 cubed, it's 27. So I'll try 3 to the 4th power. There we go, we got our 81. So I know that my log is equal to 4, because that's the power that I found worked. Okay, so here's what we had. So basically, I'm just saying that I found that power that works, and it's 4. So your solution is 4. You evaluated it, it equals 4. Okay? Part B. Again, every time we're evaluating, we're trying to find the power. What power is going to make this log true? So this one has a base of 1/2. I'm trying to figure out what power of that is going to give me 8. What power of 1/2 is going to give me 8? How can I go from a fraction to not a fraction, just a regular whole number? Or you can think of this as 8 over 1. What kind of power is going to flip my fraction so that the number is on top and my 1 is on the bottom? Well, we kind of went over it in example 2. If you look at some of the problems in example 2, you can see that you had some of those negative powers that made a fraction into a whole number, or a whole number into a fraction. So whenever I'm going from a fraction to like a whole number, my power is going to have to be negative. So I know it's negative something. I just need to figure out negative what. So I think it helps to just kind of look at the denominator and figure out 2 to what power is 8. 2 squared is 4. So 2 cubed is 8. And so it's going to be -3. And you can always check it on a calculator. If you did 1/2 to the -3rd power, you would get 8. You could go to Google Calculator and test it out. Do 1/2, 1 divided by 2, or you can use your, actually, I don't think there's a fraction button on this one. 1 divided by 2, power, -3, gives me 8. Okay. A lot of times with the fraction ones, you're going to have a negative. Here's another one with a fraction. This one's a little different because you're starting out with a whole number. You're trying to figure out 5 to what power is 1/5. Well, just look at the 5s. 5 to what power is 5? 5 to the first power is 5, but it's not just 5 over here, it's 1/5, so I need to make it negative. So if I did 5 to the -1st power, I would move this to the bottom to give me a positive power. 5 to the 1st power is 5. Okay, and then part D, I have 9 is my base. To what power is 3? 9 to what power is 3? I'm going from a bigger number to a smaller number. So I know it's not 2 because I'm not saying 3 to what power is 9. It's 9 to what power is 3. What would I have to do to 9 to get 3? Thinking in the terms of exponents, not division or addition or subtraction. Thinking as exponents. I know if I square root 9, I get 3. So you just have to think, how would I write that as a power? A square root, remember you really have the little 2 right there? A square root is the same as a 1/2 power. So I would have to do 9 to the 1/2 power to get 3. So the answer to this log is 1/2. I have a little note down here and it just says you can never have something such as log base 2 of -1. Why not? So a base of 2 to what power equals -1 is basically what this one is saying. I'm never going to do power and get something negative as long as this number right here is positive. Even if I did a negative power, like a -1 power, that's just going to turn it into a fraction. If I did a fraction power, it's just going to give me something smaller. 1 point something. I don't know what the square root of 2 is, but that's basically what this is saying. So you're never going to get a solution here. There's no power of 2 that's ever going to give me -1. It's not possible. So if this is positive and this is negative, you would just say something like this is undefined because it's not possible. Okay, a couple more things to talk about. We're almost done. We're going to talk about the common log and the natural log. And these are the buttons on our calculator. So if a log has a base of 10, it's called a common log. And we don't typically write the 10. So if you ever just see log and then a number right here, that log really has a base of 10. It's just invisible. We don't see it. We don't have to write it. It's called a common log. And you're basically figuring out 10 to what power gives us this number here. And luckily, when we have a common log, we can do it on the calculator. Unlike in example 3, all of those ones that we went through, there's no button on our calculator for a base of 9 or a base of 2 or a base of 15, whatever our base is. We only have a button on our calculator for a base of 10. Same thing goes with a base of e. If a log has a base of e, and we've talked about e before, remember e is about 2.7 and it repeats. If a log has a base of e, it's called a natural log, and we have an ln button on our calculator for that. So instead of writing log base e, we just write ln, and that's called a natural log. I don't know why it's ln instead of nl. That would make way more sense, natural log, but ln represents the natural log, which is a log with a base of e. So in example 4, we're going to evaluate these logs, and we're just going to use a calculator for those because we have common logs, logs with base of 10, and natural logs, logs with base of e. So all you're going to do is type log 5 on your calculator. It really has a base of 10, we just don't write it. If it has a base of 10, we don't write it. So we're going to do log 5 on our calculator. Let me go do it. So on Google Calculator, here's your log and your natural log button. So if you want to find log 5, you just type log 5. And I believe on our notes it said round to the thousandths place. So it'd be 3 decimals. So it'd be about 6, 9, 9, because this 9 would round the 8 up to a 9. So 0.699. And we're rounding, so that's why I use my approximation symbol. So what this is really saying, and we would never be able to figure it out without a calculator, is that, remember, there's a base of 10 here. 10 to about the 0.699 power equals 5. Now, if you type this on a calculator, you're not going to get exactly 5 because we rounded this, right? It was a decimal that kept going, and we just rounded it to the third place. But if we tried it, we would get something very, very close to 5. So 10.699. Let's just try it. So 10 to the 0.699 power is about 5. If I had to round this, I would round it to 5, right? Let's try the next one. So next one is the natural log of 0.1. So here's your natural log button. 0.1. And we're rounding to the thousandths place. So this place right here. So I'm going to look at the 5. The 5 is going to round my 2 up to a 3. So negative 2.303. Negative 2.303. Okay. So what this one is really saying, remember, natural logs have a base of e. So if I did e to the negative 0.2303 power, I would get something very, very close to 0.1. Okay. You can always check it. Next one is log 7. Go back to Google Calculator and type in log 7. And we get about 0.845. The 0 is not going to change the 5 any. 0.845. Okay, again, natural or common log has a base of 10. So if you did 10 to the 0.845 power, you get something very close to 7. And then the last one is the natural log of 0.25. And we get negative 1.386 because the 2 is not going to change my 6. Negative 1.386. Okay, again, if you did e, because that's my base when I have a natural log, to that power, you can get something really close to 0.25. All right, so that is the basics of logarithms and natural logarithms. You guys have a set of practice problems to do, which are included in the module for today, the assignment for today. If you have any questions, make sure you contact Mrs. Spizzelli or myself.